So fortunate. So, you have already learned a lot of things about how multi-agent works and how intelligent information system is designed for different industrial applications. Though it should discussed in the first class of the lecture in the course, but due to scheduling issues, it was not done. So today I will be discussing what is agent, what is multi-agent system, how they work, and how the agent technology evolved from the traditional computer system to the agent technology. So these are the brief overview. So there, if you see, there are 5 trends of computing system. The first one is ubiquity. The second one is interconnection, intelligence, delegation, and human orientation. These are the 5 modern trends of any computing system. And if you come to the ubiquity, what is ubiquity? Ubiquity means the computer system is available in everywhere, starting from mobile phone to any electronic gadget, your microwave, fridge, AC, everywhere. Even if you purchase a very low-end car, starting from Nano to Mercedes-Benz, everywhere you won't found anymore the mechanical fuel injector, rather a new version of the fuel injector that is controlled by microphone service system. It's called MPFI, multi-point fuel injector. So you won't find anymore the carburetor. So computer system is everywhere, and because the reason is the cost of processing power decreases dramatically, as said by Moore's law, that in every 18 months the cost of computing power will be decreased. How? So this has made it possible to design more powerful computers than mobile device such as smartphone and tablet computers available. If you see, if you just take an example, in 2000, when I was a student in this institute as a BTech student, I purchased a desktop computer with 64 MB RAM. 64 MB RAM, 10 GB hard disk, and 533 Celeron processor. Now, today, if you purchase, of course, the modern students who purchase the mobile phone, that is of 8 GB RAM. Okay, 8 GB RAM, 128 GB memory, processing power is huge. Okay, so the thing you see that happening maybe 20 years back in my case, 20 or maybe 22 years. So within this span of time, you see the change. Now within a 10,000 rupees mobile phone, you will get a lot of processing power, which I did not have even in my desktop. So the cost of processing power decreases enormously, and that leads to availability of computer system in everywhere. So that is ubiquity. The second is interconnection. Today, if you are given a laptop or desktop free of cost, and the condition is it is not connected on, it cannot be connected on internet nor the Wi-Fi. I have doubt whether people will carry it to their home or not, because it will simply like a dumper, nothing else. So today, whenever we think of a computer system, the first thing, whether it can be, it is having Wi-Fi, it is having RJ45 cable. Can I do my all internet jobs with this machine? If the answer is no, it is nothing but a dumper. Because today, whatever job we are doing, whatever task we are performing in the computer system, are likely to be connected on internet. Starting from Google Drive, Dropbox, to hotel booking, to food delivery, to whatever job. Forget about the computer science type of job. Even a low-end job that we are doing, it needs a connectivity. So today, finding a standalone machine is very, very difficult. You cannot think a banking system without internet, without connectivity. Today, you find very less customer in the physical bank because people do most of their work on mobile phone. I mean, I cannot remember when I last visited the bank physically. Even few months back, I was bound to install Google Pay in my mobile phone. I was bound because there is no other option. If you have Google Pay or Phone Pay or Paytm, you don't need to find out the exchange or change whatever in the bank, in the shop. So you can buy a 2 rupees fuchka and you can pay it with. So the only thing that you need to have is connectivity. Without that, it is not possible. The third thing is intelligence. What is intelligence? It is the capability of computing system to solve complex tasks. Capable of solving complex tasks, which we as a human being can solve the same thing we expect the computer will do. So that is called the capability of intelligence or intelligent system. The next is delegation. Today we expect that whatever we are doing, we expect that our computer system will do the same job for us. We are thinking of autonomous car. Fly-by-wire airplane or autopilot mode. And even I personally witnessed the driverless car in Shanghai the last July. They are testing on the road. In the real road, they are testing driverless car. So the thing is, they are replacing a driver by a software system who is controlling the entire car. So what is our expectation? Our expectation is this system will be functional like the human being. What as a human driver will do, the same thing will be done by a computer system. So gradually the thing is moving like this, that whatever the day-to-day work which are monotonous in sense will be delegated to computer system. So this is called delegation of tasks. Next is human orientation. The last one is the human orientation. Increasing use of metaphor that better reflect human intuition. 20 years back, even if you have the computer, you cannot think that computer can listen your words. But today you can operate a computer by your voice, by your finger touch. So you don't need to write the code or don't need to write the command every time. So as if it is something like another human being, you have a friend. You are talking with like a human being. You don't need to type something to Google, search it in the Google. What you can do, you just go for audio and you write it, you speak out that I want to search this thing. Google can automatically detect your voice and it will convert it, and accordingly it will start searching and the result will be. I don't think it is very far from now that tomorrow maybe some system will come where you just say that transfer 10,000 rupees from my account to maybe my parents' account, or pay this amount to this bank, or pay to this amount to Fuchkawala. You don't need to scan it, then write the code, write the amount, all these things you don't need to do. I mean, maybe within 2-3 years you will have the same facility that to get 2 fuchka and you want to pay 5 rupees. So just you say your personal device, pay the fuchka wala 5 rupees. Automatically the 5 rupees will be deducted from your account because the system will detect your voice that this is the person whose this account is. So authentication will automatically. You don't need to put the 6-digit PIN. You don't need to scan it.
If there is 3 or 4 fuchka wala, then payment can go.
Yes. If you you must have a unique identification.
There are 3 or 4.
थोड़ी वाला को दे दो. थोड़ी वाला है ना? उसका वाला का मालिक का नेम है थोड़ी वाला. उसका आईडी है. Okay. हबीब सैलून को दे दो.
Just like wireless transaction.
Same thing. Everyone will have some kind of ID, identification. So it will sense like a human being. You are interacting with a human being. It's not like a machine. Rather, the machine will behave like a human being and you are interacting with a human being. So that level of automation and human education we are moving towards. Because 100 million people connected by email once seemed to be a science fiction. Even maybe when I was in third year student, so that time we had an electrical subject, electrical circuit design or something like that. That time we found one professor, a new professor who came from IIT Kharagpur. Somehow I was very close with that professor during the semester course. So I occasionally used to visit his home in the campus. So one day he told me, Animesh, I have to go for checking an email. So where should I go? I will go to Recall Park because Recall Park there is a cafe. So why don't you go with me? So I was curious. इनका पास email ID है. ये email ID क्या होता है? So the thing is, email ID was for me that time. Email ID was so big thing that this is the person in my known region who has email ID. Now it is difficult to find a person who don't have email ID because the moment you have a mobile phone, you must have an ID. You have to create an email ID. Otherwise, you cannot run your Google phone. So, hundreds of millions of people connected by email once seemed to be a science fiction. Similarly, maybe today's science fiction will come. जहाँ पे तुम बोलोगे कि हरिवाला से 5 रुपया का फुचका खाया, उसको 5 रुपया दे दो, and your system will transfer the money because your system can recognize your voice, and you also recognize Hariwala as a unique person. He knows his ID and all, so it will transfer your amount from your account to Hariwala's. Even today, I think already you have seen. I am the last person probably who saw this thing. In this even Chandu stall or in any grocery shop, Chandu stall or grocery shop, you will find that each Paytm and Google, they have a speaker. They put their fees, they deliver the item, and you said, "Sir, I want to pay through Google Pay or Paytm." So you have the scanner, you scan it. By the time that grocery people is doing his own job, after sometimes Amitabh Bachchan will say, "आपका रुपया में क्या 500 रुपया आ गया, दे दिया सज्जनों." The thing is, the person who was working in the grocery shop, he don't need to be so careful. Even just 2 days back, I saw that he can repeat it. I mean, if he is not confident that it was, somehow he missed that to listen it, just click it, replay the same audio to reconfirm that the money is this is or not. The thing is so easy, so comfortable. Okay, so Once it was, this is this. Okay. So now so computer system paradigm, this is the, if you see the programming progression in computer system, the first level of programming was machine code. Everything you need to write it in the form of 0 and 1, binary machine code. Then this machine code has been converted to some kind of assembly language, which you have some kind of opcode. Addition has an opcode, division has an opcode, subtraction has an opcode, storing has an opcode. So then comes to the assembly language. So both machine code and assembly language are machine dependent. If you write a code for a particular type of machine, you cannot transfer that code from one machine to another machine and can execute it, because the code is specific to that particular machine. So that opcode or the assembly code, they are heavily dependent on machine architecture. So putting a layer on it, you will find machine independent programming language like Fortran, COBOL, where you can write a code and that code can be transferred from one machine to another machine and can be executed in a while. So these are not dependent on any physical machine. Then you have come the subroutine or function kind of thing, where the large program can be divided into small piece of separate code, which can be called several times for execution. So you have subroutine, the procedure and function, and then finally the abstract data type like the coding like C++, Java, these are the things. And then you have object. And finally, we are targeting our object to agent system, where agent is more like an autonomous system. So one is the object, and parallelly you are thinking of agent system. So what is the difference between object and agent? Intelligence and autonomy. Object means in each and every time you have to say how you have to do it, how you can do it. But if it is an agent, then you will just say that I need this job. It is the responsibility of the agent to organize itself to perform the task. You don't need to say repeatedly what you have to do or how you have to do. Once I say I need this job, he will do it at any cost. This is agent. So more autonomy. But for the object, each and every time you have to say repeatedly how you will do it. So that is the difference between object and agent. So from the computer science point of view, agent is more abstract than an object. Because in object, the more features you put and give a kind of interface to act like an agent. So object plus some kind of autonomy for performing the task that behave like an agent, or that can be called as an agent. Special. So delegation and intelligence imply the need to build computer systems that can act effectively on our behalf. Peter repeatedly said that self-organization, organized, or collective intelligence. Basically, and adaptive scheduling. These are the key words he was repeatedly using for the last 3 days. Adaptive scheduling. The agents will adapt depending on the changes in environment. The scheduler will not repeatedly say, or there won't be any human being who will schedule it. For example, if you go in the evening to any bus depot, particularly the SBSTC bus depot, in Tram Road you have an SBSTC bus depot. If somehow in the evening, if you go to ask for the next day's bus, you will find there are 3-4 people who are scheduling all the buses for the next day. The objective of Peter's discussion is that manual scheduling will be depending on the bus, route, different constraint, the schedule will automatically be generated. Just you need to give the input, for example, which are the routes you have, how many buses you have, how many buses are in a working condition, etc., etc. The schedule will automatically generate. And if there is any unforeseen reason, unforeseen situation happens, that will also be taken care by the system itself. As a human being, you don't need to repeatedly say to the system that you schedule in this way or you manage this way. And that's why he is using the term self-organization, collective intelligence, and adaptive scheduling. So computer system expand, and these issues were not studied in computer system earlier. So all of these trends have led to an emergence in a new field of computer science that is called multi-agent system. So what is agent? An agent is a computer system that is capable of independent action on behalf of its owner or user. So I have an agent, but the jobs that is supposed to be done by me, instead of me, he will do for me. The example, if you forget the computer system for the time being, the easy way to understand that is this idea that you have a travel agent. I mean, there is a travel agent, and you want to go to some particular place, maybe Simla with your family, and you are so busy that you don't have time to search for hotel, search for flight, search for train, and find out the schedule, which are the places to visit, how, etc., etc. So what you can do, you can deploy a travel agent. You can deploy a travel agent, and you will say your requirement. What is the requirement? The requirement is you would like to visit Simla. The probable date of visiting you give, and approximate budget you can give. So based on that, he will make a plan for you. That this date you can leave from Durgapur. In this date you will be reaching to Delhi, then from Delhi to Calcutta, then Calcutta. While going, you can avail toy train. While coming, you don't need to take toy train. You can directly come to nearby station and etc., etc. What are the places that you can visit in these 4 days? That will make a plan. Once you reach to the toy train station, how you will be picked up from the station to the hotel, the car will be arranged. So each and everything will be taken care by your travel agent. You don't need to say how he will contact the car driver, how he will book the train, how he will book the hotel. You don't need to say. What are the different places that you can visit? You don't need to say. He will make a schedule. Based on your requirement, you can make a schedule. Even he can suggest you that you have a kid, so you can go for this. If you have an agent person with you, then don't need to go to that place. So accordingly, he will make a plan for the entire 5 days plan and will make it available to you. So for that, he will charge you. The same thing here. So the idea is you are a very busy person, but you don't have time, but you have money. So instead of wasting time you are wasting. I mean, you are giving money to a travel agent on your behalf. He is doing for you. The same thing here. The agent will be doing on behalf of its user or owner. So that is a human agent. Here, a computer system working as an agent, virtual agent, or virtual software, or you can call it as a robot or rather swarm robot. Anything you can call, which has the autonomy, which has a capability to perform an independent task independently. So agent is capable of independent action. Agent action is purposeful. Whenever agent is performing any task or doing any job, it has something in his mind, just like a human being. That's why it's called purposeful agent, because whatever agent is doing, it is doing for a particular purpose. That can be optimization, that can be time optimization, that can be cost optimization, that can be quality optimization, whatever. But there are some purpose in the agent's mind. So most widely accepted definition of agent, an agent is anything that can perceive its environment. It can perceive its environment through its sensor, act upon that environment through its effectors. So an agent can sense the environment through sensory input. After sensing, it will compute it and will perform some task on the environment, and that will change the environment. So in one state, agent perceives the environment, it computes something, it operates on the environment, and there is a possibility that the environment has changed. Next, the multi-agent system. When one agent is not sufficient to complete a task, it may perform it may form a group of agents working together. So the example can be soccer player, football player, where a single player is not sufficient to compete with an entire team. So it needs to form a group of team members. And of course, the group of team members will have different capability. Of course, all will not be the goalkeeper. All will not be the striker. So, depending on the requirement of the team, constraint an agent, and accordingly the agents are chosen to form a multi-agent team. Same. Abstract way, both are same. Swarm means the capability is very less, computing power is very less, memory is very less. There is no difference. Ultimately, if you talk in the sense of abstraction, both relates to the same idea. So a multi-agent system is one that consists of number of agents which interact with one another and perform a task. So what is agent autonomy? A system is autonomous. When you say an agent and system is autonomous, if it requires little help from human. Once you design that system that we were discussing, me and Peter, that you have a number of delivery boy, delivery companies, you have number of restaurants, you have customers. There are 3 layers. You design the schedule. Once the system is designed, if I call it is a fully autonomous system, then you don't need to bother about the scheduling of the delivery boy or the scheduling of the order preparation. The schedule will automatically generate to you, and accordingly, depending on the capability, each restaurant will prepare the food and will hand over to the delivery. On the other hand, the delivery boy will pick up the food and will place it to the respective customer's house. So you don't need to repeatedly say how they will do. The system will generate the schedule. So if it requires little help from the human user, if we don't have to tell it what to do step by step. Once I say that I need this document, it will be done by the respective person. I don't need to say that this way you do, save it in Excel, save it in PDF, then resend it, then cut it. There are 45 students, so 2 will be deleted. All these things I don't need to say repeatedly. Once the job is done, it is the capability of the agent, or rather it is the smartness of the agent, that agent will do everything. If it can choose its own goal and the way to achieve it. So whenever an agent is working, it has, as I said, it is purposeful. So purposeful means it has some goal in its mind. And according to that goal, it will try to achieve it. If its behavior is determined by its own experience. Because that agent may have, so if you say that it is a learning agent, it can learn. So you can keep some kind of memory in the agent's design that it can hold some previous state and its failure and success both. So based on the past experience, it can do. Just like the human being, we know that based on the previous experience, we can behave in future. If its behavior is determined by its own experience. If we don't understand its internal working mechanism, as I say, you don't need to say repeatedly how. So it is more like the details is encapsulation, encapsulated. As an outsider, you cannot say how it is being done. Very simple example, the abstraction. Earlier it was the fluorescent tube. Now most of the people used to write LED tube. So what you are doing, you are bringing the LED tube, connecting with the same wire. That's it. You don't need to bother how the LED bulbs are installed in the tube, how the fluorescent was manufactured. You don't know because it is a job of somebody else who is doing. You are just paying that thing and you are getting. Simple abstraction. Another form of abstraction is you don't need to bother how the. Can you say the electricity that we are using? It is an hydrogen power or thermal power design electricity because that is abstracted from us. We pay the money, we are purchasing the electricity. How it is generated, where it is generated, when it is generated, we are don't bother about that because these are all abstracted by my service provider. I know I need electricity. I took it from State Electricity Board or DVC. They are providing me the electricity, but how they are purchasing it, where they are purchasing, whether they are producing it at their own, we don't bother. We need milk at our house. We take it from maybe Amul or maybe from some Gola. I don't need to bother about the maintaining the cow in my house. The same thing applicable for computer system also. We use Google Drive, we use Dropbox, but we don't need to bother what hardware they are using, where they are maintaining the server, how many replications they are doing. So these are kept hidden from us. That is abstraction. They are abstracted from us.
So basically here, we means the end user.
Yes, we means the end user. So we don't need to understand the internal working principle of agent. Okay, so once, for example, if you take the example of Peter platform, as a Swiggy user, Swiggy delivery boy or the restaurant people, you don't need to understand that how the platform is running, how many agents are there, whether it is an agent-based design or an object-based design. You don't need to bother about it. You don't need to be an expert of computer system. You don't need to be an expert in the computer system. So there are three desirable properties of an agent: reactivity, proactivity, and sociability. So reactivity is, it is an intelligent agent should respond in a timely fashion to changes they perceive in their environment. If there is a change in anything in the environment, they will respond. That is called reactive agent. Something is happening in the environment, something changes in the environment, and accordingly the agent is reactive. The example can be thermostat. Thermostat. There is another behavior that is called proactive. I said that I need to put the tag on the file. Immediately one of my students goes to bring the paper, then glue, then sticker, then sketch pen. I said only that I need to put a tag on the file. I have never said that I need glue, I need white paper, I need sketch pen. On its own design architecture, you understand that Sir wants to put a tag on the file. So what are the things possibly that may need? As a smart guy, I need to arrange for that. Because the next things I will be asking for this. So before Sir asking, I am arranging all these things. That is called proactive behavior. The other thing can be, I need this thing. He is bringing that. So one is reactive, another is proactive. So the proactive behavior can be based on the knowledge base, based on the past experience. The proactive behavior happens. The third one is social ability. Intelligent agents can interact with other agents. It's like a human society, which is something that has been repeatedly discussed by Peter is collective intelligence. Not the intelligence by one agent is sufficient, rather it is a collective collection of intelligence. I mean, intelligence of a collected people or swarm of agent or swarm of robot. So these three behaviors should be there for an intelligent agent: reactive, proactive, and social ability. So understanding reactive behavior is very easy. Proactive is also what is the possibility that may require, and social ability. It is the ability of agent to interact with other agent. As I said, that in our inauguration session, I told that we need to organize the inauguration session. I have the full faith on my student that they can easily organize this thing. I did not need to say anything that what song will be there, what are the other things that may require. They arranges the entire schedule for them. And who are the person who can possibly sing? They arrange it. They are the person who chooses the person who will anchor. So all these things can be carried out by the team of students themselves. So they have the capability of forming society. They have the capability to interact with each other to achieve a common goal. What was the common goal? The common goal was to successfully organize the inauguration. That was the common goal. So to achieve that common goal, they interact with their fellow friends, their junior, their senior, maybe student from other department, and they form some kind of team. So that is called social ability. So this is an example of reactive behavior. When there is a change in the environment, or the weather is very hot in the room, the thermostat start working and the AC switch is on. When it is too cold, the thermostat will switch it off and the AC will be cut out. So that is a reactive behavior. That you cannot say it is an intelligent agent. So just by having the reactive behavior, you cannot say your agent is an intelligent agent. Sensor. Just only that. So purely reactive agents, purely reactive means decision is only on present state. As there is a change in temperature, so the thermostat works in that way. That is called purely reactive. Every purely reactive agent can be mapped to an agent's defined runs. The reverse is usually not true. Thermostat with two environment state. Agent, AG is the agent and E is the environment. Thermostat off, heater off, if E is equal to temperature, okay. Else, heater is on. This is the only two state. So there is a sensor which can sense the environment and sense the temperature of the room and based on the temperature of the room, it will switches from on off or on. So what is an environment? The environment is the entity in which the agent is situated. It is in this environment that agent senses and acts. So see the typical example or a picture. And you can call it as a bee, a sort bee, which senses its environment. It senses its environment through its sensory. That is called perception of the environment. It is perceiving the environment through eye, doing some kind of computation. With hands and legs, it is doing some action on the environment. So, perceiving the environment and then reacting on the environment. And as a result, there might be a possibility to change the environment. The environment state changes from one environment state to another environment state. Now, there are different type of classification of environment that I am not going into detail of that. So, if you see from the computer science point of view, so an abstract agent architecture. If you describe an agent architecture, assume a discrete finite set of environment. The collection of, so E is a collection of environment. E1, E2, E3, dot, dot. Assume an action of agent defined by AC. So there can be several actions that an agent can take during its performance. Idea: an environment state starts at some state, and agent chooses action in which state, in each state, which leads to a new state. So the thing is, an agent is situated in an environment. Based on its perception, it performs some action that leads to the agent from one state to another state. And on that state, again agent performs some action, it leads to a new state. So every time the agent is performing an action, it leads to a new state. So this is called a sequence of interlinked environment and states. R. It was in environment 0. It performs a task alpha naught. It reaches to another environment E1. In E1, it should be alpha 1, alpha 2. Okay, that's a mistake. So E1, here it performs another task alpha 1 that leads to a new environment, new state, that is called E2. In E2, it again performs alpha 2, it reaches to another state. It's not alpha 0. These are alpha 1, alpha naught, alpha 1, alpha 2. It's a mistake, typing mistake. So this is called a run. So a run is a sequence of interlinked environment and states. And from change of this state is done based on the action it is performed. Okay, so this is called start state transformation function. Pi R AC that leads to rho E, which maps run ending with an agent action with a set of possible resulting state. So if you start from one state, you perform a set of action, and that is complete run, and that leads to a new state. It depends on the history of previous state. It depends on uncertainty, non-determinism modeled by the allowing or multiple successor states.
The result state could be another set of possible results.
হ্যাঁ, মানে যে কোনো একটাই হতে পারে তো। It is in one state. On that state, agent is situated. It performs some task action, it will lead to another state. But you cannot determine which state it will go. In more general sense, an agent is a function. Mathematically, you can define, or in a formal mathematics, you can define. In the most general sense, an agent is a function, AG, RAC, that leads to an AC. If set of all agent AG defined by a system of pair of agent and an environment NB. So the denote the run of system are AG and environment. So the collection of AG and environment. One AG and a set of environment states. And that will lead to a terminal state at the end of the run. So that is the end of that run. Okay. So some more mathematical design.
This environment is the ontology.
That environment is not ontology. Ontology is something like you are in which state, and that will lead to which state, the knowledge base of the agent. So এজেন্টের যে লজিকটা, সেই লজিকটাকে তুমি বলতে পারো অন্টোলজি, on which logic it will run.
The logical depend on action and
And the logical action. ফ্রেমওয়ার্ক আমি বলবো না। ফ্রেমওয়ার্ক মানে হচ্ছে ফুল সিস্টেমটাকে বলা যেতে পারে। এজেন্টটা অন্টোলজিটা হচ্ছে একটা কাইন্ড অফ নলেজ বেস, যে নলেজ বেসের উপরে এজেন্টগুলো চলাফেরা করছে। So agent is something like a kind of moving element which are moving on the basis of that knowledge base. মানে তুমি বলতে পারো তুমি মাথাটাকে নলেজ বেস বলতে পারো বাংলা ভাষায়, মানে খুব লুসিড পেজে যদি বলা হয় তাহলে মাথার যে লজিক্যাল অ্যাসপেক্টটা সেটা হচ্ছে ontology.
So here the proactive agents and the social agents, they may be in
Of
these
course,
cases,
yes,
the ontologic may be
কিন্তু
there.
তারা করছে কি করে?
based on some knowledge. So
Based on some knowledge.
So
সেই নলেজটাও কিন্তু ontology।
exactly.
সেই লজিকটা, সেই নলেজটাই হচ্ছে কিন্তু ontology. So ontology কে তুমি বলতে পারো, ontology you can call ontology as a framework for knowledge base. Framework for knowledge base. But framework, it is not framework for the agent. It is a framework for knowledge base. মানে যে নলেজ বেসটাকে you can expand at your own will. মানে simple example of ontology, let me tell you. Forget the timing, forget about computer science. I always prefer to give this type of example. And now the age of my daughter is 10 years. Maybe 7-8 years back, when she was in 3 years, something like that, 2-3 years age. So during that age, if someone, maybe my student or maybe any person who goes to my family to visit us, if he is a male person, she undoubtedly said uncle. If a woman of your age goes to my house, she undoubtedly said auntie or pishi. If the same thing happens in her maternal house in Asansol, if a woman come in the age category of my wife or less than that, she undoubtedly say Masi. And if a male person come when the age of his mama, she used to call her mama, him as mama. Nobody said. So the thing is, उसका दिमाग में ये घुस गया, यहाँ पे जो आती है, so पिशी, काकू, फिर संपर्क. Similarly, the same thing happens in Asansol. She used to call Mama. But if the same thing happens, for example, मेरा मम्मी का कोई दोस्त आती है यहाँ पे, तो उनको मेरा बेटा, nobody used to call her as Dadi. So maybe in future, maybe at the very beginning, once or twice she was said that in this age you can call it as Takuma or Dadi, Masi or Mama, and gradually she applied this thing. ये आएगा तो मासी है, ये आएगा तो पीसी है, ये आएगा तो मामा है. So you can call that she has a basic intelligence. On that basic intelligence, she is building his knowledge base over the time. Over the time, she is building the knowledge base. That you can call it as one word. And structured information. And through that, she can also conclude something, she can also perceive something, she can also infer something. जे एक भद्रमहिला আমাদের বাড়িতে এসেছেন, उनका एज इतना है, so probably I should call her as PC. So based on the past history, she can infer it. So before doing that, she has to perceive the environment. How? Because both are lady. The person who at the age of you and the person who the age of my mother. Both are lady. But she can see that this lady is of this age. So probably she will be of kind of my Takuma's friend. So I should call her as a Takuma. But same thing, if you go to my house, you will be called as Pishi or something like that. Okay, should this you can call as a knowledge base, this you can call also as one knowledge. Some structured information in her brain. And with that knowledge base, he is doing different kind of activities. So that you can call as an agent's activity.
But knowledge base তার উপরে আবার নতুন কনস্ট্যান্ট গুলো চেঞ্জেস হবে।
হ্যাঁ, তুমি knowledge base টা বাড়াতে পারো।
দিয়ে স্টেট চেঞ্জ হচ্ছে ওগুলো।
হ্যাঁ,
এখানে সেমনি এনভায়রনমেন্টের স্টেট চেঞ্জ
হচ্ছে।
ওই রেসপেক্টে হলো এনভায়রনমেন্টের
না এবার এর ইন্ট্রোডাকশনেই তো ওটা আছে যে এআই এর যখন ফার্স্ট ইনোভেশনটা স্টার্ট হয়েছিল তখন ওইভাবেই স্টার্ট করা আছে যে নলেজ বেস দিয়েই এআই আগে চলতো। এখন যেটা আমরা প্রেডিকশন এই সবগুলো করছি আগে এগুলো নলেজ বেস দিয়েই হতো। আগে যেরকম একটা মেডিকেল এআই জেনারেটেড নলেজ বেস ছিল যেখানে মাইসিন ছিল, তো এইভাবেই হতো যে এই পেশেন্টটা এলে যদি এই সিম্পটমস থাকে তো সেজন্য কি কি টেস্ট থাকবে বা কি মেডিসিন থাকবে প্রাইমারিলি ওগুলো ওখান থেকেই হতো, এটা নলেজ বেস থেকেই হতো। এআই এর একদম প্রাইমারি স্টেজে এই জিনিসগুলো ছিল, মাইসিন ছিল আরো এরকম অনেকগুলো।
ওটাই বলছি সেই রেসপেক্টে এনভায়রনমেন্টাল
সেই সময় তো only সেই সময় the mycin is kind of expert system, but there was no concept of agent, the autonomy.
ওটা একদম প্রাইমারি
Yes.
স্টেজে এআই ছিল।
So how it is different? That's what I want to mention. That when you call about simple expert system or mycin kind of application, that was a knowledge base that can of course infer, but there was no concept of agent or multi-agent. There is no concept of proactive behavior. There is no concept of societal behavior or society formation or social behavior, social activity. where you can feel that multiple agents will work together to achieve a common goal. Here the common goal is to generate a schedule with a minimum cost or minimum time or maximum quality or maximum profit. So there can be different application of agent technology. It can be transportation, logistics. It can be workflow, business process management, distributed sensing, information retrieval and management, electronic commerce, human-computer interface, virtual environment, social simulation. Social simulation. I think many of you are already familiar with this term, distributed sensing. It's a very common example today, putting the CCTV. What are the minimum number of CCTV that needs to be installed in the campus to cover major areas to find any intruder? So I am trying to find out minimum number of CCTV cameras such that it will monitor all the points where possibly the intruder can come in the campus. Or what are the minimum number of sensors that will be installed in an environment to sense maximum possible area? Or in a particular moment, which of the sensor will be active? Because the sensors are power sensitive. You cannot keep the sensor running for 24/7 because there is an issue with power. So, when which sensor will be on, which sensor will be off? Can you make a schedule that to make a set of sensors to be active? So, distributed sensing. Another example is social simulation. So, we were discussing with one of our colleagues in China a few years back. I think all of you are familiar with the different scheme of government. For example, Konyasri, right? Konyasri. Yes, Konyasri. Sobusati. Central government, they have also different scheme.
Ayushman Bharat.
Ayushman Bharat. The question, Ayushman Bharat, then Jawan Navodaya Vidyalaya. Jawan Navodaya Vidyalaya is a very, very innovative project. Jawan Navodaya Vidyalaya. Jawan Navodaya Vidyalaya. Jawan Navodaya Vidyalaya, I don't know. Jawan Navodaya Vidyalaya is one of the, I think that is one of the greatest intervention of the project central government have ever designed for the underprivileged. It is a special type of school entirely funded by central government. The primary criteria to get admission, you should be in a rural background. You should be from a marginalized family, preferably with a marginalized caste also. And you will be given full funding. Starting from shoes to yes, yes, everything, accommodation, everything, both for boys and girls. And after 12, if you get admission in NIT, IIT, all tuition fees, hostel fees will be borne by government. কিন্তু ওখানে পাওয়াটা জয়েন্টে পাওয়াচ্ছে কোনো কিছু কম।
Sir, how to get Prime Minister?
Okay. So the idea is, so there are, for example, in Durgapur, there is only one, of course, in one big city, there is only one Jagannath.
Every district.
Every district
District-wise.
district-wise. So Durgapur Vidanam. The idea is, so now listen, what is our involvement, social simulation? How many students can be admitted in Jagannath Vidyalaya in a year? And the students who are graduated from that schools, how they are benefited and how their family is benefited in long run, that will be simulated in a simulation environment and checked for 20 years. So 20 years you cannot wait. You are running a simulation environment in 2 days for 20 years. And you want to see that if this project runs for 20 years, how it will perform. What my point? So instead of waiting for 20 years to instead of doing that, you are trying to simulate the 20 years in 2 days. And you want to check how this system will function in 20 years. And tune the issue accordingly. Similarly, for Punnasri, it can be done. Similarly, for all other schemes. Mainly the socio-economic schemes that are designed for by the state government and central government. Okay. So agents as a paradigm for software engineering, interaction is most important aspect in complex software system. Ideal for loosely coupled black box component. Agents as a tool for understanding human societies. Human society is very complex. Computer simulation can be useful. This has given rise to the field of agent-based social simulation. Now you may have, some of you may have doubts still, how they are different. Agents and distributed system, agents and economic or game theory. When you talk about agent or multi-agent system itself is a distributed system. When you talk about multi-agent system, it is definitely that the agents that you are deploying are not running in the same system. Rather, they are running in a different system in different nodes which are connected in the network. So, agents versus economy, distributed rational decision making, extensively studied in economics. So, game theory very popular and many strength, but also some occasions. So, in game theory concept, you have agents. So, I mean, in game theoretic approach, there is a use of agent that is known as such. You cannot distinguish that game theory and multi-agent system. So, agent or multi-agent system is a tool which are used in the game theoretic system. I have already discussed agent versus object. Agent is more autonomous. More autonomy is there. Agents versus expert system. Expert system, as I said, it is more like a knowledge base. It is a collection of huge knowledge. You can infer something from that knowledge base. But you don't have to, you cannot think of and social ability or proactive behavior. So when you talk about agent, it is more proactive and social ability, where multiple agents have a collectively working together. Then you have another idea, intentional system. There is a concept called belief, desire, intention. So initial knowledge base that an agent has is called the belief base. And intention, where you want to reach. A goal, yeah, goal and intention, how it will reach there. I can example show you this. মানুষই হয়ে যাচ্ছে। Okay, belief, desire, and intention. The diagram is like this. You have a sensor input, belief revision. So the belief is always evolve করছে, adaptive. Then desire, intention to perform an action to reach there. Okay. Now, here for this particular Gian workshop, we are more focused on this particular slide. Coordination, cooperation, and collaboration, where multiple agents are coordinating, they are cooperating, and they are ठीक है चलो ओके थैंक यू তোমাদের কিছু বক্তব্য থাকলে বলতে পারো আর আই উঠে একবারে